Let us discover additional columns for our frequency distribution. Welcome to STATScreen. This is still for frequency distribution. There are additional columns that we can create for any frequency distribution. For this, let's consider the simple frequency distribution given below. The first column that we could add is what we call as the column for class boundaries. The class boundaries are actually considered as the true or the real class limits. Why is it that they are called the true or the real class limits? Let me discuss it like this. Let's consider two class intervals here. Let's start with 21 to 25 and 16 to 20. When we say 21 to 25, it means that it includes the values 21, 22, 23, 24, and 25. For 16 to 20, this includes the possible observations recorded as 16, 17, 18, 19, and 20. But the thing here is that not all data that we will be observing soon are in integral form. Some of the data can be continuous in nature. If we talk about 21 to 25, it includes all the data in continuous form from 21 to 25. If we talk about 16 to 20, it includes all the decimal values from 16 to 20. However, there are data that can't be recorded when we just focus on the class limits, speaking of which are those values from 20 to 21. There are values here in decimal notations. To do that, we are going to come up with the class boundary as it includes those unrecorded labels or limits. In this case, we'll have to average it. So from 20 to 21, let's divide it for two different class intervals, and it would be 20.5. This 20.5 would be the upper class boundary of the class interval 16 to 20. And this will also be the lower class boundary for the next interval 21 to 25. With this, all the values, considering presence of continuous data later, will be catered for our frequency distribution. To continue this, we will just simply try to add both upper and lower boundaries with the class size or width. Our class size or class width here is 5, indicated by the number of possible values in integral form for each class interval. Just like for 21 and 25, we have 5. That's why the class size or the class width is 5. And we'll be adding it to both class boundaries. Therefore, the next values are 25.5. It will be the upper class boundary of the second class interval. We just simply added 5 from 20.5. Conversely, we could also just simply look into the value when we add 5 to get 20.5. So that's 15.5 instead of 16. The lower class boundary becomes 15.5. And it follows like this as well. So this is how we add class boundaries for our frequency distribution. The next column that we could add is what we call as the class mark. Class mark or class marks is considered as the midpoint or the midpoints of each class interval. This is very important because one of the formulas that will deal with a certain measure of central tendency for a group data which is represented for the frequency distribution, this is very important for the formula and needed to solve such. The class mark, being the midpoint, can be computed like this. Let's consider first this class interval 16 to 20. The class limits here are 16 to 20. And specifically, 16 is your lower class limit, and then your 20 is your upper class limit. We know that for 16 to 20, we have the values 16, 17, 18, 19, and 20. We could just automatically pinpoint our midpoint here, or our class mark for this given class interval. That's the middlemost value, and that would be 18. So this is our class mark for our first class interval. But we also have a formula for this. The formula goes like this. We simply try to average the upper and the lower class limits, or we add them and we divide by 2. So for this class interval, the same class interval, to check whether it's really 18, we just need to add 16 and 20. But the formula is actually written wrong, but nevertheless, addition is commutative. It should be 20 plus 16, but nevertheless, again, addition is commutative, and we divide it by 2. So our result is 36 over 2, or in simplified form, 18. This proves that the previous answer of 18 using the middlemost value for each class interval being our class mark is correct. To complete this column, we also use the same class width or class size, and we add that to our first class mark to get the next class marks. Take note, our class size or class width is 5. In short, the next class mark is 23, and to be followed with 28, and then 33. So this is how we solve the class mark. The next column that we could add is what we call as the relative frequency. The relative frequency is important in a sense that it could also be used to describe our set of data, because it talks about the percentage of observations that will fall in each class interval. Notice that for each class interval, we have class frequency as given here, 6, 12, 18, and 4 respectively. Talking about percentage, that's your relative frequency. First, getting the total class observation, and it could be solved when we just simply add the total frequency. And the total observations is equal to 40. This is our base as we were going to solve for the relative frequency for each class interval. And it's computed in this manner. The relative frequency for each class interval is simply the frequency of that class interval to be divided by the total observations times 100, and then that's in percent form. So for our first, we will have 6, that's our class frequency, to be divided by 40, and we multiply it by 100. The relative frequency for the first class interval is 15%. For our next class interval, it's 12. That's the frequency for the class interval 21 and 25, to be divided by 40, and then multiply by 100%, or simply 100. And you place the symbol for percent. This would mean it's just 30%. And then it will follow so on and so forth. 45%, and you will have the last one, 10%. You would know that your answer is correct by looking at the relative frequency, and if you're going to add them, it should total to 100%, since you're just using the same total observations 40, and it should complete the percentage. Before we continue, as of the date of publication of this video, only 36.1% of the viewers in this channel have subscribed to the same channel. So it's just a few of the total of viewers that is recorded. So if you would like to, you could subscribe and be the next person, be the next subscriber for this channel, and this percentage may increase. Thank you in advance. Let's continue to our last column that we could add for our frequency distribution. But for this, we could add two separate columns, for there are two different cumulative frequency for every frequency distribution. Generally, the cumulative frequency is the number of observations above or below a specific class boundary. So let's try to separate them into two. The first cumulative frequency that you could add is the less than cumulative frequency. It's defined as the total observations smaller or lesser than the interval's upper class boundary. Don't worry about the confusing definition. We'll have an example for this. And let's try to represent that here. The less than cumulative frequency is again related to your upper class boundary. So looking at our class intervals, let's try to determine or review what are the upper class boundaries. And for the first class interval, it's 20.5 because again, we consider the continuous type of data that may be included. So let's focus first for this class interval. The question is, how many observations are less than or smaller than 20.5? How do we answer that? Look at the class frequency. We have 6, right? The 6 being the class frequency of the interval 16 to 20 indicates that there are 6 observations of values ranging from 16 to 20. Again, this 6 values ranges from 16 to 20. None of them are greater than 20, and of course, none of them are greater than 20.5. In short, we are sure that these 6 are all less than 20.5. That's the less than cumulative frequency of your first class interval. Again, because we are sure that of these 6, they all ranges from 16 to 20, so they are all smaller than 20.5. For the next class interval, its upper class boundary is 25.5. Now we are to ask, how many observations are lesser or smaller than 25.5? Now you might say it's 12 because using the same concept earlier, the class frequency of the first class interval is 6, then your less than cumulative frequency is 6. Now you might say 12. You're halfway correct. Yes, this 12, which belongs to the class interval 21 to 25, are all smaller or lesser than 25.5. And of course, they are part of the result, but they do not complete the result. The answer here also includes the earlier 6. Notice that those 6 earlier are values from 16 to 20, and obviously they are also smaller than 25.5. In short, to solve for this, we add 12 and 6 to get a result of 18. This is the total number of observations lesser than 25.5. It's not just 12, but includes the 6 before it. Using that same concept, when we reach the third class interval with the upper class boundary of 30.5, it includes 18, the 18 meaning the class frequency for this class interval, and all the values before it. In short, we have 18, we have 12, and 6. Therefore, the final result is 36, because that's 18 plus 18. And finally, for our last class interval, 35.5 being its correct upper class boundary, the less than cumulative frequency of our last class interval is 4 plus the previous answer involving 18, 12, and 6, which equals to 40. You would know that your answer is correct because once you reach the final column, or row rather, for your less than cumulative frequency, it totals, or it is equal to the total observations of 40. If it's less or greater than 40, then you might want to review your process. The next and the last column is for the greater than cumulative frequency. Now we are on the different concept now. It talks about the total observations larger than the interval's lower boundary. Again, larger than the interval's lower boundary. For us to do this, there is an easier process for that. Earlier, take note, for less than cumulative frequency, we started with the smallest, or the interval with the smallest value. And then we worked from there, adding all the frequencies and reaching 40. For this, let us try to start with the largest interval, because it talks about the larger, the values or the total observations larger than interval's lower boundary. So if I'm going to add it here, greater than cumulative frequency, and determine the lower class boundary of the last interval, which is 30.5, we are to count the number of observations that are greater than 30.5. Now, for this last interval, there are 4 observations with values ranging from 31 to 35. Again, there are 4 observations ranging from 31 to 35. And they are all of these 4 are greater than 30.5. So we start with that. We simply add it there. And that's your first greater than cumulative frequency. We started here so that we could work it backwards. The next is for the lower class boundary of the third class interval being 25.5. And we are to write or count the number of observations larger than this lower class boundary. Notice that for this class interval, the class frequency is 18. In short, 18 observations has values ranging from 26 to 30, and they are all greater than 25.5. But it's not just 18, same as earlier. It's 18, and then you add there the 4, because those 4 with values ranging from 31 to 35 are also greater than 25.5. And as therefore, your greater than cumulative frequency here is 18 plus 4, 22. Now for our next class interval, the lower class boundary is 20.5. So it includes the value of 12, the value of 18, and then 4 as well. So 12 plus 18 plus 4, you will get a result of 34. And finally, for our last class interval, for its greater than cumulative frequency, since its lower class boundary is 15.5, we include the 6 and all the values greater than that, because we are assured of that aside from 6, the 12, 18, and 4 class frequencies for the next class intervals, they are all greater than 15.5. And of course, including 6. That's 6. You will have 12, 18, and then 4, which totals to 40. You would also know that your answer is correct here, because the first, or the greater than cumulative frequency for the smallest, or the smallest class interval is also the same as your total observations of 40. So this is your greater than, and earlier your less than cumulative frequency. Again, just a review, you would know that your answer is correct if the total observations of 40 matches with your last less than cumulative frequency and your first greater than cumulative frequency. If it's less or more than that, review your process, because you might have committed some errors along the way. Now I would like you to try this. I would like you to give the class boundaries, both upper and lower, the class mark, the relative frequency, and the 2 cumulative frequencies of the specific second class interval using this given simple frequency distribution. Again, only for the second class interval. And if it's not too much, I would like you to share your answer on our comment section. I will be waiting for your answers and be verifying them if they are correct. This is your STATScreen.